In this video, I'm going to be going through linear regression and particularly the very basics of it. All right, let's get started. So the first thing that I'm going to do is I'm going to be importing NumPy, and then I'm going to be importing some of the plotting tools from Matplotlib. Okay, so let me just create X first of all, right? So X in this case is just a bunch of numbers from -5 to 5, linearly spaced, right? So we got 100 such points. And Y in this case is going to be 2 times X plus 3. If you already know about linear regression, I'm not going to introduce any noise in this particular case, all right? So I'll come back to that in a bit. But so let me just plot it out, and you will see this nice line as you would expect. And by the way, if you're wondering why it's not going through 3 on the intercept, just keep in mind 0, 0 is in the middle over here. Okay, so with linear regression, what we really want to do is we want to minimize errors. Okay, so in this case, I want to show you this loss function. So in this particular case, I have the error is simply y, so my observed output, minus a function of x. Okay, so I haven't mentioned x over here, but f is a function of x. But also my parameters. So in this case, the parameters are w and b. And the reason that I'm choosing these parameters is because I'm limiting my function to be in this shape, right? So it's going to be wx plus b, w times x plus b. Okay, so what I want to do is take these errors, square them, and then sum them. So that is a particular instance of a loss function that I could do. I could have easily done instead of np square, I could have done np abs instead, right? So numpy.abs, but we're not going to focus on that case. We can just use numpy.square. All right, so let me just do that. So Python knows what my loss function and my f is. So just in case you want to see what y is, so that's what I've just printed out the numbers over here. Right, so you don't have to do this, but again, x over there. And just as an example, the loss function, if I take 2 and 4, it's 100. So let me just go back here to my original actual function. So my actual function is 2 times x plus 3, right? So if I put in 2 and 3, my loss function should be minimized. So in this case, it should be 0. So let me just put 2 and 3 just to show you that it is indeed, 2 and 3, I get 0. Okay, actually I've done that in the next step. Okay, all right, so what I want to do is I'm going to try a whole bunch of values for w and b. And then I'm going to see at which point does the error get minimized. So obviously I know that it's going to get minimized at 2 and 3. But the point is I needed some sort of an algorithm to do that. All right, so I'm going to have a whole bunch of numbers from -4 to 4 for W, and a whole bunch of numbers for -4 to 4 for B. Okay, this mesh grid thing, what it does, so let me just show you what it does actually. So if I plug in W try now, so if you can see, it's -4 to 4, but it repeats. Okay, it repeats horizontally. Now, if I was to look at B try, actually, I don't think it's going to work. Give you a good example here. Right. Okay. Actually, never mind. It does. Right. So B try, it goes -4 to 4 vertically. Right. So and the reason that we do that is we get all possible combinations of these numbers. Right. So I'll get a 100 by 100 matrix, so that I can run through all my possible combinations of W and B tries. Okay, and that's exactly what I'm doing over here. So I'm going to run through all my possible combinations of W and B's and look it up against the loss function. Right, and then I observe all the errors over here. Okay, so this over here is my really rough algorithm to find the best W and B that fits this particular thing. And when I do plot it, when I plot this thing, the W, so I think one of the axes is W try, the other one's B try, and then the colors is basically the more red it is, the higher the error. Okay, so in this case, you can see at 2, 3, which is my true value, you'll find the minimum. And you can see these nice little curves happening. Now, when we come to real-world linear regression problems, we're not going to try all possible values, right? So we're going to do this thing called following the gradient. It turns out for linear regression, at least, the solution is a straight-up answer. So you can find this thing straight away. You don't need to do any fancy gradients or such. There is such a thing. So I'll just quickly show you. If I just all you need to do is Google linear regression on the Wikipedia page. I hope you can see this in your thing. Let me just quickly show you the solution. Right. So this thing over here, the coefficients that you're after, you can simply get it through this thing over here. All right, and that's all I'm going to show for now. But that is the solution for linear regression. But again, when the problem's too big, when you have too many observations, you kind of ignore that, and there are other rough methods of doing it. And we can cover that later. Okay, all right, so I have mentioned the maths over here if you do need it. And you're welcome to come and inspect it. But honestly, in the next tutorial, I'm going to go through scikit-learn. You really don't need to know. This is really an optional thing. If you want to know the maths, go for it. There's all the gradients and stuff up here. And I will stop there for now. And in my next video, we're going to go through scikit-learn. Thank you.